In 1964, a Soviet astronomer named Nikolai Kardashev proposed a strange but brilliant idea. Instead of measuring a civilization's advancement by its technology or culture, measure it by one single number: how much energy it can actually control. He called it the Kardashev Scale, and it ranks civilizations not by what they've built, but by how much of the universe's power they've learned to harness. Right now, humanity doesn't even qualify as a Type 1 civilization. We're still climbing toward it. But today, we're going to skip ahead. What would it actually take, and what would it actually look like if Earth became a Type 3 civilization, one capable of harnessing the energy of an entire galaxy? Before we climb, we need to know our starting point, and it's humbling. Current estimates place humanity at around 0.7 on the Kardashev scale, meaning we don't even fully control all the energy available on our own planet yet, let alone the planet's total potential. A true Type 1 civilization would harness roughly all the energy that reaches Earth from the Sun and exists within the planet itself. Solar, geothermal, tidal, everything, fully captured and usable. We're not there. Most of our energy still comes from burning fossil fuels, a tiny, inefficient sliver of what's actually available to us. Let's take the first real step. A Type 1 civilization has full command of its home planet's energy output, an estimated 10 to the 16th to 10 to the 17th watts, harvested from every available source. Solar panels covering vast regions, complete geothermal extraction, full tidal and atmospheric energy capture. What would that actually look like? Structures like theoretical Dyson swarms, vast networks of solar collectors, those scaled down to partially ring the Earth or sit in orbit, capturing sunlight with extraordinary efficiency. Weather itself might become partially manageable, not through magic, but through the sheer scale of energy available to influence atmospheric and oceanic systems. Global energy scarcity, resource wars over fuel, and blackouts would become historical footnotes, artifacts of an earlier, energy-poor era. Here's where the scale becomes almost incomprehensible. A Type 2 civilization commands roughly 10 to the 26 watts, essentially the entire energy output of a star like our Sun. The most famous theoretical structure associated with this level is the Dyson sphere, or more realistically, a Dyson Swarm, a massive network of orbiting collectors surrounding the Sun itself, capturing nearly all of its radiated energy rather than letting the vast majority simply scatter uselessly into space. Building something at this scale wouldn't be a matter of decades. Most serious estimates suggest a project like this would take many thousands of years, even with extremely advanced technology, given the sheer volume of material required, potentially dismantling entire planets or asteroid belts just for construction material. At this stage, humanity's energy concerns wouldn't just be solved, they'd become almost meaningless. Interstellar travel, even at significant fractions of the speed of light, could become genuinely feasible, since propulsion systems could draw on a virtually inexhaustible power source. Here's a detail that surprises most people. The jump from Type 2 to Type 3 isn't just a bit more energy, it's staggering. A Type 3 civilization commands roughly 10 to the 36 watts, the energy output of an entire galaxy, containing hundreds of billions of stars. That's not 10 times more than a Type 2 civilization. It's not 100 times more. It's a difference of roughly 10 billion times the energy output. To put that into perspective, the jump from Type 1 to Type 2 is comparable, proportionally, to the jump from a single light bulb to the entire output of the Sun. And the jump from Type 2 to Type 3 is that same kind of leap, applied again at galactic scale. This is why many scientists consider Type 3 not just a distant future for humanity, but potentially a fundamentally different category of existence, one that might require abandoning biological bodies entirely in favor of some other form of intelligence better suited to surviving and operating across such vast timescales and distances. To harness the energy of an entire galaxy, a Type 3 civilization would need some way to capture power from a significant fraction of the 100 to 400 billion stars in a galaxy like the Milky Way. That likely means not just one Dyson swarm, but an enormous number of them, built around countless individual stars, all coordinated as part of a single galaxy-spanning infrastructure. Communication across a structure this size becomes its own enormous problem. Even at the speed of light, a message sent from one edge of the Milky Way to the other would take roughly 100,000 years to arrive. A Type 3 civilization would essentially need to solve the challenge of coordinating a society where the fastest possible communication between its own members takes longer than the entire history of human civilization. Some theoretical physicists have proposed that such a civilization might become detectable to us specifically because of this, by looking for unusual infrared signatures in distant galaxies, evidence of waste heat radiating off millions of Dyson Swarm-like structures. Several real astronomical searches, including projects analyzing data from infrared satellites, have actually looked for exactly this kind of signature, without finding conclusive evidence so far. This isn't purely theoretical daydreaming, it's an actual area of scientific research. Projects like the GHAT survey, Glimpsing Heat from Alien Technologies, analyze data from NASA's WISE infrared space telescope, scanning roughly 100,000 galaxies specifically for the kind of unusual waste heat signature a Type 3 civilization's massive energy infrastructure might produce. The results, so far, found nothing conclusive. No galaxies showed the telltale infrared excess that would strongly suggest large-scale artificial energy structures. That doesn't rule out Type 3 civilizations existing somewhere in the universe, but it does tell us that if they exist, they either aren't common, aren't detectable with our current methods, or don't build the kind of massive heat-radiating structures we've been searching for. Realistically, based on our current rate of technological and energy progress, most serious estimates suggest humanity is centuries away from even reliably reaching Type 1, let alone Type 2 or Type 3. The jump we walk through today spans not just enormous amounts of energy, but almost unimaginable stretches of time, potentially hundreds of thousands or millions of years of continued civilization, survival, and advancement. But thinking through this scale isn't pointless. It reframes what progress even means, not as building more stuff, but as learning to capture and use the energy that's already all around us, largely untapped. Every incremental step toward Type 1, here and now, is a step on the exact same ladder that, taken far enough, leads somewhere almost impossible to fully imagine. If you enjoyed this journey up the Kardashev scale, subscribe to the channel and let me know in the comments, do you think humanity will ever actually get there?